right, so our warm-up is going full screen. One, let's see.
So for number 6, we'll need.
All right, begin. The first one, there is something in common to every term. What's in common to every term? X. We call that the GCF, the greatest common factor. So we write that in front, and then we divide each term by X. What we're left with is that. Is this fully factored? No. When you've got an X squared, it's very possible that you can factor it further. We want to try to get all of our factors down to linear terms. Doesn't always happen, but we try. First terms are going to be X and X. We need two numbers that multiply to give us negative 12 and add to give us negative 4. Now, without the signs, if we just think about 12, 1 and 12, 2 and 6, 3 and 4. We have, will 1 and 12 be able to come together to get us negative 4? No. What about 2 and 6? Yes. What about 3 and 4? No. It's 2 and 6, right? So you've got your numbers, 2 and 6. You got to figure out your signs. If you multiply to get a negative, that means the signs have to be the same or opposite? Opposite, right? So now you have to decide, do I want to subtract the 2 or subtract the 6?
Okay.
Why the 6?
Because it's a negative 4.
Because it's a negative 4, right? Yes, so we're going to do plus 2 minus 6. There's our factors. I'm going to show you another way to do this in a moment. Actually, I'm going to show you on the next problem. When you are finding out what makes this equal 0, there is a property called the zero product property. The zero product property says if I have something times something and that product equals 0, one of those terms has to be 0, right? You're not going to take 1 times 3 and get 0. The only way you multiply two things together and get 0 is if one of them's 0. Do you understand that? Okay. Well, think of any other number, right? Oh, I heard someone say no. Is that Mary? No? Am I lying? Okay. All right. Well, anyway, it's true. The only way to multiply two numbers together and get 0 is if one of them or both of them are 0. So because of that, we have 3 things here being multiplied together. X plus 2, x minus 6. This times this times this. That's why they're called factors, right? Because they're being multiplied. So if this times this times this, if x times x plus 2 times x minus 6 equals 0, that means either x equals 0, or x plus 2 equals 0, or x minus 6 equals 0. X equals 0 is done. How do I solve this? What do I do to both sides? Subtract the 2, and I get x equals negative 2. What do I do to both sides here? Add 6, and I get x equals 6. Now, I have 1, 2, 3 solutions. What's the degree of the original polynomial? 3. Do you guys know degree means highest exponent? The highest exponent of our original polynomial was 3. Do you think it's a coincidence that that was an x cubed and we had 1, 2, 3 solutions? Yeah. That's the fundamental theorem of algebra, right? Okay. So your number of solutions has to match the degree, but you can have repeats, right? I could have x equals negative 2 and x equals negative 2. So you might have a repeat. That's okay, but there's going to be 3 solutions. All right, I'm going to move this stuff down. Okay, let's go with this color. Now, when you're trying to figure out two numbers that multiply to give you something and add to give you something, we like to think multiply to 12 and add to 11, but that's not true. If there's a number in front, you gotta put that with that. You think outer and inner. Multiply to the outer, add to the inner. The outer number, if you take those two numbers and multiply them together, what's that number? 24. So you need two numbers that multiply to give you 24 and add to give you 11. So let's think about it. 1 and 24, say yes or no. No? 2 and 12? No. 3 and 8? Yes. 4 and 6? No. 3 and 8. That's your pair. Now, you can't do x plus 3, x plus 8. If I FOIL this out, am I going to get this? No, because x times x is not going to give you 2x squared. So what do we do instead? So I saw a group in the back who shall remain nameless, but did a very interesting technique that I love. They did something called factoring by grouping. And I'm going to show you. It's really fun and simple, and it's like foolproof. Now, the trick, though, is you have to know how to split this up. So we just figured out it was 3 and 8, right? Now, we could put 8 and 3. You'll get the same answer either way. Makes no difference. So I just took the 11, split it into a 3 and an 8. Is that okay? Look at your first two terms. What's the GCF? X. Pull it out front. What's the GCF of the next two terms?
4.
4. Now, let's look at what's left. We have two terms. You guys know terms are things separated by a plus or a minus. We have two terms. There's a GCF in these two terms. It's 2x plus 3. I'm going to pull it out front. If I divide this term by 2x plus 3, I'm left with x. If I divide this term by 2x plus 3, I'm left with plus 4. And there's my factors. How fun is that? Now, you've done that before. It's just been a while. But you have. Right, Caitlin? Yeah. All right. If you, quiet down, please. Now, quick question. Do I care how you factor as long as you can get to the correct factors? No, you can factor them however you want. So if you don't want to learn this method, which I didn't put these in parentheses. If you don't want to learn this method, you don't have to, right? I don't care. If you can do this with guess and check, do it with guess and check, right? If you want to do it with the snowflake or the star, that's fine. If you want to do it with the T-chart, that's fine. Whatever works for you, right? Okay. Either way, the most important thing is you've got to be able to solve this equation. So you set your factors equal to 0 for this first one. If I solve this, I'm going to subtract a 3, divide by 2, and I get x equals negative 3 halves. If I set this factor equal to 0, subtract a 4, negative 4. I have two solutions. Does that make sense?
Yes.
Yes, because this is, by the way, does anyone know what we call an equation that has a degree of 2? It's quadratic, right? Very good. It's quadratic. If its degree is 3, anyone know what we call it? Cubic. It's a cubic. Yeah. Okay. All right, last one. Hey, is there something we could factor out of every term before we start? There's a 2. 2, if we're factoring, the 2 has to stay out front. This one's a pretty straightforward one. There's no leading coefficient other than 1. So factors of 15 that add up to negative 16. So 15. We got 1 and 15 or 3 and 5. 1 and 15. So we pick the 1 and 15. We got to multiply to get a positive, which means the signs have to both be the same. But we have to add to get a negative, which means the signs have to both be negative. Bam, bam. Now, technically there are 3 factors, but there's only 2 with variables. If you set the first, here, I'm going to rewrite it. If you set the first factor, this 2 equal to 0, that's just silly because 2 will never be 0, right? So that's fine. So you set your x minus 1 equal to 0, add 1 to both sides, and you get x equals 1. You set the x minus 15 equal to 0, add 15 to both sides, and you get x equals 15. We have 2 solutions. Does that make sense with our degree? Yes, because it's a square. All right. Today, we've already done factoring practice. That was the first part of our warm-up. There's a reason for it, because we will be doing more factoring today, right? Yeah. Ashwin, you looking forward to it? Let's get out some paper. Let's get ready to take some notes. This is section 2-3. Gentlemen in the back. Let's put that away. Okay. When you were in Algebra 1, you solved systems of linear equations. You did this again last Thursday. It is time to move into Algebra 2, which is solving systems of nonlinear equations. If there is not enough room for this, you guys think like you're going to squish the whole group move forward the whole foot, and then you two can turn and face the front. You don't have to, but you could. There. Okay. Okay. Here's what I want you to do in your groups. I am going to, let's see. So I'm going to assign you a letter. A, B, C, D, A, B, C, D, A. All right? Your job is to come up with every possible number of solutions. Now, on Thursday, we talked about a line and a line. If you have a line and a line, a line and a line, you can have one solution. You could have 0 solutions, or you could have infinitely many solutions, right? What I'm looking for from your group is to draw a little sketch of each possible number of solutions for your shapes. So for number 1, we have a line and a parabola. Think about, can I have none? Can I have 1? Can I have 2? Can I have 3? Can I have 4? Can I have infinitely many, right? And if whatever numbers you come up with, you need to have a sketch that backs up your number choices, all right? I'm going to give you about 90 seconds in your groups to see if you can come up with all the possibilities. All right. Tell me, line and parabola, what's the lowest number you can have?
0.
Good. Good. Okay. Yes, you're right. Yes, I'm talking to the front group, but yes, it's great in the back too that you got 0. So, line and parabola, 0. They just never touch, right? Good. What else? Can you have one solution?
1.
Yeah. Yes, you can. So, one solution. It doesn't have to be at the vertex of the parabola. We were kind of talking in the back. It could be along the side. And it'll still just intersect. It's what's called tangent. If it's tangent to the parabola, it's just going to touch that one spot. So, one solution. What else?
2.
That's good. How do you get 2?
If it
Just goes through it. Good. Can you have 3?
No.
No? 4?
No.
Infinite?
No.
You sure?
Yeah.
You're going infinite? Okay, so we have this discussion in the back too. So one group was thinking possibly infinite because they were thinking, well, what if this, like, as the parabola goes like this way where it gets steeper and steeper, the line kind of follows along. And There's always an angle. I know, yeah. It never actually becomes linear. It looks like it does because it gets so steep, but it never actually does. So yeah, no, it's just 0, 1, or 2. All right. Group B had 2 parabolas. What's the lowest number of solutions you can have with 2 parabolas? 0. 0? I love that. Okay. If they're not touching, right? And they don't have to be like opposite. You could have one inside the other, and that's okay. You still have 0. All right. What else? Can you have 1? Okay. Tell me how you have 1. Okay. So when in 3rd period, my brain, for one, was thinking that they're touching at the vertex, right? Which is fine. And then another student said, hey, what if it's the same parabola that's just been shifted over? That also will only have 1. So, yeah, there's many ways to get 1. All right, good. What about, is that it? Just 0 or 1? 2? How do you get 2? Push it up a little bit so you get that. Okay. Same thing. Can I get anything in between? Can I get 3? No? You sure? 4? You sure? Front group is saying yes. Do you guys hear Ashwin up front? What if we did that?
Oh my God.
Nobody said they had to be vertical. Right? So we got 4. All right. Do I hear 3?
Yeah.
All right. I'm so curious. How do you get 3? So take this one. Intersected at the vertex. Now we've got 0, 1, 2, 3, or 4. Do I hear 5? 6? None? Just infinity after that? Okay, you're right. All right. Good. See, good. We're pushing our brains a little bit. All right, circle and a line. Group C. You guys. Okay. So what's the least number?
0.
0. Okay, what's next? 1. How do you get 1? Just touches it tangentially. Okay, yes. 5. I'm going to teach you something right now. Being tangent doesn't mean you only touch in one place. Being tangent means that the line has the same slope as the circle at that point. So I always have to talk about geometry, the failures of geometry, that this line right here is tangent, but it can still intersect the curve at other points, right? So tangent doesn't mean I only touch once. Tangent means I have the same slope as the curve at the point of tangency. All right, sorry, go ahead. I digress. So what's next? What else? 2? 3? 4? 10? Infinity? No. Just 0, 1, or 2. Unless we get into non-Euclidean geometry, right, where a line can bend. But we're not doing that. Okay. All right. Good. Put D in the back. All right. Tell me circle and parabola. What's the least number? 0. Parabola, circle, they never touch. 0 solutions.
You could do 1 if it's tangent.
If it's tangent, right? Yeah. Okay. So I love that we keep using the word tangent. 1. Good.
And then you could get 2 if it's like halfway in the circle.
2.
And then you could get 4 if it's like all the way through the circle.
Okay. Pretend that's a circle. That looks more like an oval. Okay. 4.
And then after that, if it's like the same slope as the circle without any number less than infinite.
Ooh. Okay. Before we move into infinity, what about 3? Can we get a 3?
Just like 4, but the bottom.
Okay, so if we wanted to, we could have a circle. Let's see. Can we have a circle that's tangent? If I draw this right, and then cuts through two spots, something like that, right? Cuts through two, and then somehow is tangent to the other side. I'd have to find out if that's mathematically possible, but I think it might be. Okay, good. 3. So here's the thing. What you're thinking, which is beautiful mathematical thinking, is, hey, what if they kind of nest the circle into the parabola, and therefore they would share infinitely many points just in this little region right here, this little interval? Okay, except the problem is that a parabola and a circle will never coincide like this. They just truly don't have the same shape. But it's great mathematical thinking. So I really like that outside of the box thinking. So you are thinking like a mathematician, which is awesome. All right, good. Any other questions on these? Kind of just to push your brains a little bit with thinking about stuff. So what we're going to do today is we're going to solve some of these systems. Thursday, you just, oh my gosh, come on. All you did was find a little crisscrossy point of 2 lines, right? Now we're going to find, where does the line intersect the circle or the parabola or 2 parabolas, right? All kinds of different ways we can go. We're going to start with a line and a parabola. Go ahead and write this problem down. So y equals x squared plus 6 and y equals 5x. This is called a nonlinear system because the equations are not both lines, right? So nonlinear. When you are solving a nonlinear system, in general, do you think it's easier to do substitution or elimination? Substitution. I want you to get in the habit of doing substitution for these. You could do elimination with this one, and it'd be just fine, but we are going to move into harder ones where substitution is your only option. So we're going to go ahead and start right off the bat with substitution. When you solve by substitution, you have to solve for one letter in one of the equations. What do you want to solve for? Y. I want to solve for y too. All right. Since it's already solved for y, you take what y equals in one equation and substitute it in for y in the other equation. So take a moment, replace the y in the second equation with x squared plus 6. Everyone have that? All right, so on your paper, let me ask you this. What kind of an equation is this? It's quadratic. How do you know it's quadratic? Because the highest is x squared, right? All right, so we have an x squared, it's quadratic. In order to solve a quadratic, the equation always has to be equal to what? 0. So the first thing you've got to do is get this equation equal to 0. How are we going to do that? We're going to minus a 5x from both sides. Why, it's just like the warm-up. It's like we planned it. It's almost like we knew. Okay, now, in order to solve a quadratic, there are 3 different methods you can use, but the one that will work for you for almost every problem that we give you in this unit is for, what's my favorite F word? What's your favorite F word in the whole world? Factor, right? Right? Okay, so everyone take a minute and factor that. Food for me would be like 5th or 6th.
What?
It's up there. It's in top 10. Probably function. Fraction. Nope. Only one way that works. It's deceiving. The 5 and the 6, you got the choices of 1 and 6 or 2 and 3, and both can be combined somehow to get 5, but only one will multiply to give you a positive 6 and add to give you a negative 5. If you do the 1 and 6, you'd have to have one of each. Yep. Okay, so when we factor, quiet please. 5x and 6, x squared plus or minus 5x plus or minus 6, those are, even though it's easy, it's tricky because you got 1 and 6 or 2 and 3. But we got to multiply to get a positive, which means both of our signs have to be the same. And they're actually going to both have to be what? Negative. So if I did 1 and 6, I'd actually get negative 7. So I got to do 2 and 3. Now, these are not the solutions. These are the factors. Now we have to set each factor equal to 0 to find the solution. So what are our two solutions?
X equals 2 and X equals 2.
X equals 2 and X equals 3. Is that the answer to this problem? No, because when we solve a system, the answers are
Pair points.
ordered pairs, right? So I know the X's. How do I find the Y's? Plug it back in to which one? Makes no difference. And actually, both is a great answer because then you'll know you did it right if you plug them into both. Because you should get the same answer for both, right? All right. So if I plug in a 2 into the top, I get 4 plus 6, which is 10. If I plug a 2 into the bottom, what's 5 times 2? 10. Right? So I know that that's a correct solution. Let's try 3. What's 3 squared? What's 9 plus 6? 15. What's 5 times 3? 15. So there's my two solutions. Hey, quick question. What shape is this graph? Parabola. What shape is this graph? It's a line, right? Okay, so we have a parabola and a line. I'm going to show you in a minute how to check where they crisscross, but we're going to do that on the next problem. Any questions before we move forward? Yes, please. Huh? You tell me. I'm looking at these two equations. The top one's the parabola. How do you know that the bottom one is not the parabola? Because it's not squared. This one, it says here, it's just x to a single first degree. It has to be linear. Yes?
So if it's squared, it's a parabola.
Yes. Yeah, very good. By the way, I love that you said that came to that conclusion, because I learned something on Thursday. Do you know what I learned on Thursday? I learned the definition of math.
What?
What is math?
Yeah.
Numbers,
Equations.
equations, fractions,
Functions.
functions, sequences, homework, problem solving, graphing, analyzing. You know what math is by definition? Math is the study of patterns. It's the study of patterns. So when you say, hey, if you keep telling me every time that it's quadratic, that it's a parabola, then I say, oh, so every time I see that my highest is an x squared, that my graph's going to be a parabola, you're drawing a conclusion based on a pattern, and that's what math is, right? So, yes, very good. Moving on. Now, what we have, first of all, what's the graph of the top equation? That's a line. The bottom equation is called a rational function. Rational function when you have x's in the denominator. The graph of a rational function looks like that. So that line, if the line goes this way, we have no solutions, right? If the line is up here and just like touches that guy, we have one solution. If the line goes this way, we have 1, 2 solutions, right? We could also have a graph. What's really fun is if you have a graph, I can't draw it, I'm not gonna be able to do it, that like somehow is tangent to both of these, which can happen, then you could have 2 solutions, right? Anyway, a lot of different combinations. All right, how do we solve? What's our method for solving when we have a system of nonlinear? Substitution. Gosh, if only one of these was solved for y already. Wouldn't that be awesome? All right, I'm going to give you a kind of a jump start. Okay, so go ahead and replace your y in the second equation with what it is. Bless you. Bless you. Now, many of you probably not solved a system like or an equation like this before. I'm going to tell you something. This is back when you have known this since you were 8 years old, maybe even 6. I can do whatever I want to an equation as long as I do it to both sides, right? Now, I want to get rid of that x that's on the bottom. How do I get rid of an x that's on the bottom? Multiply both sides by x. Not by 8. X. Yes. Okay, it doesn't get rid of the x. But multiplying by x gets rid of the x, right? I do this. Okay. Great. Right? Hey, when I multiply both sides by x, do I just pick which terms I want to multiply it by? No, it's all or nothing. I got to multiply the whole side. So what's on the left side? What are we left with when we multiply the left side by x? Very good. Beautiful. What are we left with on the right side? What kind of an equation is this? It's quadratic, which means we need to now make sure that it equals 0, which means we're going to have to subtract 8 from both sides. Always write, by the way, do you guys know about descending order? That you always put your squared term and then your x term and then your number. All right, hey, what's our favorite F word? Factor. Go ahead and do it. Right, Jose? Yeah.
You want me to come up and do it?
No, on paper. No, this one we need a full-time staffed position. Our youth program is way too big. All right, so we have an x and an x. Okay, numbers, factors of 8. 1 and 8, 2 and 4. 1 and 8. Same sign or opposite signs? Opposite, because I got to multiply to get a negative. I want to add to get a negative. So do I want a -1 or a -8? -8 plus 1. So I get x, whoops, I skipped a step here. Stop skipping steps. So x plus 1 equals 0, x minus 8 equals 0, x equals negative 1, x equals 8. Are those my final answers?
No.
All right. If x is negative 1, what's 8 divided by negative 1? What's 8 divided by 8? 1. Those are my two answers. Everyone get out your laptops. I'm going to write these two equations down over to the side so that I don't forget them. So we have y equals x minus 7. We have y equals 8 over x.
What is it going to look like if it's a circle?
A circle and a parabola, a circle and a line.
Circle and a parabola. A parabola would be square, quadratic.
Yes, and a circle is different. The equation of a circle is x. It's technically x minus h squared plus y minus k squared equals r squared. You'd have a squared x and a squared y to get a circle. All right, so go to the internet, and I want you to go to Desmos. How many of you have used Desmos before? Okay, if you haven't, it's just desmos.com. Now, Desmos, the nice thing about it is it's so easy to use. So we're going to type our first equation, y equals x minus 7. And then just click below or enter or tab and you get, and then type y equals 8 divided by x. The divided by, use the slash that's under your question mark to do divided by. All right, now if you don't see this well, you know on your trackpad how you can like two finger make things like smaller or bigger, right? So on your trackpad, you can like kind of go like zoom in or zoom out.
It really looks like a square.
Wait. Something's wrong.
If I go closer, it looks like a
Oh, okay. Okay. Now, little trick. See where the two graphs intersect? If you hover over that, put a little click like where you're on that circle. Look at that. It tells you that point. Now you go to the other one, and there's your other point of intersection. You have my permission on quizzes to use this to check your answers, but I'm still going to look for all of your work. But you can use this to check your answers. You will not be allowed to use this on your test. So don't just rely on this, right? But it is a nice little tool for you to be able to see what the graph looks like, check your answers, make sure that you're doing things right. So Desmos. If you don't have this bookmarked, I would bookmark it because we're going to use this quite a bit this semester. Okay. I am leaving this site because we have to get through one more problem. Okay, we're going to do this. We have 7 minutes. We're not going to be able to start the quiz. But I do want to do a word problem first before we start the quiz. So, small manufacturing company wants to build a rectangular building that has 1,500 square feet of floor space. Now, square feet, 1,500 square feet, is that talking about area or perimeter? Area. Area is measured in square feet, right? So if I want a building with 1,500 square feet, I could make the building 1 foot wide and 1,500 feet long. Right? 1,500 square feet. Meets the requirements, right? Right? Yeah, I would like that, right? You'd have to be skinny. Anyway. Okay, you can make it 2 feet wide and 750 feet long. Right? That's better. Right? 3 feet wide, 500 feet long. Okay, we're getting there. All right. So anyway, 1,500 square feet of area. there are many possible dimensions, but they want the building to have a perimeter of 160 feet so that they can display this logo that they want to display on the exterior walls. So there's a certain length that they want their building to have so that they can display this logo nicely. So we need to write some equations to represent the stuff that's going on. If L is length and W is width, and we want 1,500 square feet of area, how could I write that as an equation? How is area measured? How do you calculate area? Length times width, right? So L times W has to equal 1,500. Perimeter has to equal 160. How do I calculate perimeter? 2L plus 2W. Why not just L plus W? That's only halfway around, right? If you have a building with a length and a width, and you want to go all the way around, then you have L plus W plus L plus W, right? So the perimeter, which is 160, we would write 2L plus 2W equals 160.
Is this going to be a square building?
It doesn't have to be a square building. It can be rectangular. You want, if you was square, it'd be easy, right? Your length and width would just be the square root of 1,500. Yeah. All right. You have a system of equations. 2 equations, 2 unknowns. I would solve by substitution. Personally, I would solve this equation for either L or W. Before you do anything, what can you divide everything by right off the bat? 2. So if you divide everything by 2, you get L plus W equals 80. I want you to solve this for either L or W, I don't care which one, and substitute it up into this equation and see what happens. So take a minute, solve for either L or W, substitute it up here. All right. So if I take the L and I substitute it in, so I get 80 minus W times W. 80 minus W times W is 1,500. What do I have to do first? Distribute. And I love that you're using the word distribute. 80W minus W squared equals 1,500. Should I subtract 1,500 from both sides, or should I add W squared and subtract 80W from both sides? I would add the W squared and subtract the 80W because you want your squared term to be positive. So you're going to add W squared and you're going to subtract 80W. Why am I doing all this? What does this have to equal? 0. Why does it have to equal 0? Because this is what kind of an equation? Quadratic. Don't let the hundreds scare you. Think 15 and 8. What numbers multiply to give you 15 and add to give you 8? 3 and 5, right? So instead of 3 and 5, we're going to have 30 and 50. So our length can be 30 or 50, or our width can be 30 or 50. Our length is 80 minus the width. So if this is my length and this is my width, if my width is 30, my length is 50. If my width is 50, my length is 30. So either way, my building is 30 by 50. Okay, guys, that is it. There is homework tonight. I don't know my pause.
He makes all the hard stuff and then so his homework is super easy.
2-3 tonight.
Omar.